Everyone, August 26th. All right. Well, majority of the unpacking is done, and that's actually today I had my first training session. Very light, very light, and very low volume. The main goal is just to, keep the joints moving, and yeah, it hurts. Elbow is, I always hurt my elbow. My elbow always hurt after I rest for a while because I simply couldn't get into the position that I need to. So I'll take a few sessions to loosen up. It's not a loosen up the elbow, it's basically a loosen up the shoulder. So my shoulder really gets tight after now training for a while. And just it's hard to get into those positions. So that's that. And my skateboard arrived, so I took it for a little ride today for the first time in my life, standing on a skateboard. It was very interesting. It was very interesting, and I think I made good progress. I'm able to cruise down a little bit, feel okay, but the pushing part is still tough. I still couldn't push very consistently. Like after once the speed gets up, and I got scared, and I jump off a couple of times, and also haven't even tried to do all the necessary tricks. But yeah, it's all right. I think I'm doing this in the courtyard, really, like right outside my house. I think after I got a little bit better at it, I'll move to the skate park. Yeah, so and also the unpacking is almost done. Spent a lot of time last night putting the bookcase together. It looks very nice. It's a step bookcase, big enough to hold actually all our books. And now we basically have two bookcases. One is serving as a TV stand, and the other is the real bookcase. It was good. A lot of efforts to build that up. Quite heavy, and I don't think it's basically impossible to say to move it, like to unassemble it and then to move it. No, I'm not doing that. When we need to move, I think that we'll have to have the movers take the entire thing down. Yeah. All right. Anyway, so that's that, and let's look at what we have today. Path with maximum probability. You're given an undirected graph and nodes. We have an edge list, undirected edge, A and B, with a probability of success. Given two nodes, find the path with the maximum probability of success. So it's basically because the probability of success is the multiplication, right? So if you want to find the maximum, you need to do basically I think it's a Dijkstra, right? I think it's gonna be a Dijkstra, but it's a modified Dijkstra. Dijkstra you will find, it doesn't matter the maximum sum, right, or the minimum weights. It's to find to use Dijkstra. But in this case, what we want to find is the maximum, right? The maximum product. So we use Dijkstra as well. It's going to be a max heap, right? Max heap, and each time we try to go. Actually, yeah, will it work if we want to go maximum? So we cannot return the first one, right? Because if we return the first one, it's 0.2. So what we need to do is keep running until we exhaust everything, and then return the probability associated with nodes. Okay. And everybody starts with 0, except for the starting one. And now we're just gonna go. Oh, and it has to use floating point double. Yeah, it has to use double. Which is fine, we can do double. We probably need to search online how to do Java double. Yeah, it's okay. Let's give it a shot. I don't know if it's gonna work, but I'm gonna give it a shot. We know how this thing generally works. Ugh. Right? So edges, we need to get graph. Oh my goodness. And nodes. Yeah, I like to do this. We say int edge of edges, right? We have A and B, so we say graph dot put if absent edge 0 array list right, and graph dot get edge 0 dot add edge 1. Okay, so that's to get a graph. Okay, now we're gonna do Dijkstra. We need a priority queue of double. Oh wait, hold a second. What do we need here? We need a node, so it's going to be a double queue new priority queue, and I remember we need to say AB double dot compare A0 B0. Actually, hold on. I think a better way is to negative. Yeah, so if we compare negatively, we don't have to assign them negatively. So we have the queue, and we need a double probs n, because everyone had to have it, and then probs start 1 0, and no, there's no start node, and we also need to say queue dot add new double 1.0 and start we can do that there. We can do it there, right? Okay, and it's gonna be while queue is not empty. We say double current go to queue dot poll if okay, here's what we're gonna do. Java compare to double. All right, we need a minimum. It's what? 10 times 10 to the minus 5. Okay, so usually we call this what? Usually we call this double epsilon, right? Epsilon. 2, 3, 4, 5. Okay. So we say if math.abs current 0 minus props current 1 is smaller equal to epsilon. Continue. Okay, so this we need to turn it into int. Okay. Otherwise, oh wait, hold on. If it's larger than, which means if they're not equal to, right, then we keep going. Otherwise, for child of graph.get all right, so we can say double current prob current 0 and int current node current 1. So this is current probability minus current node, right? To get current node. Okay. So we got a child and not int double temp prob shall equal to current probability multiplied by prob's child. If temp prob is larger than prob's child equals temporary probability. Yeah, if it's larger, then we'll do it. I think it should be if this minus this, right, is larger than epsilon. That means it's bigger. Then we set it to this, and then q.add new double food. Q.add child. No. Temp probability and child. We just keep going until at the end. We'll return probs and node. Okay. Let's see how this one goes. All right. Current node, child. Probability child is always 0 initially. Okay, this is not working. It can't be this way. So probability initial shall be 1. But if its initial is 1, because you're multiplying it, right? And alright, I think we should set it to -1 so we can have something to deal with. So race dot fill props with -1. Okay, this is fine, blah blah blah. And then we say if props child is smaller than 0. Then temp probability. Hold on. We can say double temp prob right here. So if we do this, we say temp prob is equal to current prob times 1. Alright, because you reach else temp prob shall equal to current prob times probs child. Do this, and then because if it's negative, then this will be a positive. Then we can assign it, and then we can do this. If it's smaller than 0, we return 0. Otherwise, we return and node. Okay, let's see. Oh, you must be kidding me. It's also not right. What the hell? Start from 0. With probability in the starting node, right? So 1, 0. Okay, current probability is 1. Node is 0. And probability is 1. Current probability 1. 1 minus 1 is... Huh. Wait, how do I avoid this? How did you avoid it? No, it's good. It's good because initially it's the same. Yeah, it's the same. So I come here, and then child is, let's say 1, right? Oh, we didn't even do any edges. Oh my god, you didn't put the... There's a success probability. I forgot about that. Holy crap. Alright, that was bad. Damn. Alright, and then this has to be a... Oh my goodness. List of... Oh, it was so wrong. Alright, so we have this. This is fine, but this is not right. Get this dot add, it has to be a double. So new double. Node success probability. You know what? Let's change it. Success prob and then node. So when we do this, it's going to be success probability I, right? These two are the same. Yeah. And edge 1. Okay. New double. Success probability I, edge 0. Okay. Now I have this. Everybody's -1. Because I can do that. Yeah, this is not right. Do you still need to do this? I don't think you need to do this anymore. Just keep it 0. Right? So you get a child, you get a temporary, you don't need a temporary, it's just the current probability times that. Yo, man, I was not thinking through. So it shall be current probability times, yeah, it's not child. Should be double node probability node. Okay. Then we can say double p prob node 0 int child this is times p. And then we say if this minus this is larger than, so if this is larger than epsilon, which means the temporary probability is larger than whatever's currently in it, then we assign it to it, then we do this. And with that, I think I can just return this, it'll be fine. Yep. I can't believe it. I completely missed it. Yeah. 0.514 standard Dijkstra, but using a max heap for finding the max product of all probabilities. Dijkstra is O V plus E, right? I think that's Dijkstra's O V plus E. Oh, shoot. Yeah, forgot. Should we get a default? Default shall be a list, collections.empty list. Oh, completely forgot about this one. Yeah. There we go. Very straightforward. Oh, Bellman Ford. Holy crap, what's Bellman Ford again? We have Bellman Ford, we have Floyd Warshaw. I forgot about Bellman Ford. Is n times n? M plus n log n. Oh, log n. Build a graph, just edge plus node log node. Ah, you can do the log. Yeah, that's not right. It's gonna be v log v. It's gonna be v log v. What's Bellman Ford again? Oh, Bellman Ford is simple, straightforward. Isn't this gonna time out? So it goes through every node. For each node, goes through every edges. Get a U, get a V. Max probability is this. Max probability U times times this because from U to basically we have U and V, right? And I have the max probability from U go to V. So with the current and best probability, you times this. If it's larger than probability V, then probability V will equal to this. We set has update. Has update. If has not update, then we break. Yes, though this looks very similar to Floyd Warsaw. What's the difference between Floyd Warsaw and Bellman Ford? Yeah, you go to 3 times. Shortest pass this, shortest pass go to a K, right? Yes. Floyd Warsaw. Didn't go through an intermediate. It directly say for each node, okay? Yeah. For each node. Where is I used? Hold a second. Where is I used? You just go through all the edges and you try to see if it will have update. Huh? Really? Wait, what does Bellman Ford do? Bellman Ford. Shortest path from one city to all the other. A given vertex and every other vertex. Negative cycles. I just want to see the algorithm. Everybody is distance. Relax all edges. Oh, we just do it that number of times. A simple shortest path from source to any vertex can have at most v minus 1 edges. So you go at 1 time. This is directed graph, right? So this to U, to this to W, U to W, or U to V, right? If it's smaller, we'll update it. So we go there once, and we go another time, so we go with V number times. Huh, interesting. Ah, interesting. That's the last one. Yeah. Hmm. Yes. Hmm. Relaxing -1 times guarantees that the algorithm has explored all possible paths, length up to n-1. Wow. So Bellman Ford is one, a single source, um, single source minimum distance to everybody else, right? Floyd washout is any pairs. Ah, because you have a starting point. That's the single source. So it's asking, starting from a certain node, what is the minimum? Floyd washout is given what is the minimum between any two. I mean, technically you can do, yeah, I think technically you can do Floyd washout as well, but Floyd washout is take longer. It's OV triple. Yeah, this one is shorter, it's better. Oh, yeah, makes sense. Makes sense. But of course, neither is as good as Dijkstra. In this case, Dijkstra is much faster. Yep. Alright, that'll be it. I'll see you guys tomorrow.